So, hello friends, we're going to start with chapter 8 static electricity. Okay, okay, so the first concept is electric charge. So, basically, as you see above, there are some experiments that when you rub a plastic comb over your hair, you attract some pieces of paper. The third thing is far more common if you rub a blanket with your hands. That happens very much in the cold weather. While adjusting the blanket, we sometimes rub our hand and we see a spark. Okay. So what the observation is that electric charge is physically everywhere near us. Okay. It is stored even in our own bodies. So every body is made up of very tiny particles and electric charge is there. See, every body is made up of atoms. Okay, an atom has has a large positive charge and small, let me change the color, and small electron charges. Not the very best structure maybe, but you will learn about that. Okay, then you go to study chemistry in the higher classes, you will learn how to define the structure of an atom. Okay, so electric charge is present, it's present everywhere, it's in a hidden state. Why? Because as the statement reads, this is because two opposite charges are present in equal number in all these substances. When a substance I say is neutral, I mean it's not positive negatively charged, it doesn't mean it does not have those charges. It means the charges are effectively cancelled by each other. Okay, as this says, if the charges are not balanced, the object is said to be charged. Basically, if there are 3 plus and 1 minus, then there are 2 plus atoms. It's positively charged. But when there are 3 negative, okay, but if there are 2 positive and 2 negative, then it is said to be neutral. Okay, so where is the experiment of try this? What you do is you take a glass of rod, rub it against a silk cloth. Basically, silk cloth is a really good conductor of electricity. That is why they said when there is lightning going on, do not try to touch silk. Okay, due to rubbing, a small charge, as I say, will get transferred from one object to other. As a result, objects will become somewhat charged. Okay, you freely suspend it in air and bring another glass rod. Now the glass rod is also rubbed and it also has same charges because both are rubbed with the same kind of fabric, silk. What you do is you bring these two together. So as you see here, these two repel each other. So what we derive from it is that like charges repel each other. Okay. Now bring a plastic rod. Plastic rod, remember, hasn't been exposed or hasn't been charged. Okay, when you bring it closer, these two start to attract each other. The glass rod goes in the arrow direction and the plastic rod goes towards the glass rod. This basically implies this happens because the plastic rod has both positive and negative ions. The negative ions are attracted towards the positive glass atoms. Okay, so what do you find? Two rods carrying, I'm here, two rods carrying similar charges push each other away. This is called repulsion. We learned from second experiments that rods carrying opposite type of charges get pulled towards each other. This is called attraction. Okay. So what is the origin? As I have explained that basically in atom you have a stationary positive charge, it does not move, and mobile negative charges. These are negative charges which are scattered around. Though not the ideal structure, but at this stage it's enough to know. Okay. But these two charges balance out each other. For example, there are 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 negative ions. So in this big structure we have 10 positive. Overall electron is quite neutral. Electron is, sorry, the atom is electrically neutral. Okay, but for some reason, if this neutrality is disturbed, then charges come into play, as it's written. For example, when certain objects are rubbed against each other, the negatively charged on one object goes to the other object. Basically, negative charges are transferred from one object to another. Positive charges are not transferred per se. Okay. Similarly, the object from which the negatively charged particles go away becomes positively charged due to deficiency of negatively charged particles. Okay. So let's do an experiment that basically you rub with it with paper and observe whether they get attracted or not. So one thing is, the term amber was called electron. I mean, it's not important for question's sake. Amber is called electron in Greek language, and this property of amber to attract things was named electricity by Thomas Brown. Not important for questions maybe, but a good fact to know. So what is frictional electricity? Remember that we generated the charges through rubbing. So that rubbing generates friction, and the charge which are generated by the friction is termed frictional electricity. Now one thing is, this charge is produced only at the place of friction. So for instance, this is the rod and I rubbed only here. So only this place will have some positive or negative ion depending upon the material. These are technically neutral. Okay. The charges of static electricity are absorbed in moist air. This is why experiments should be performed in dry weather, particularly in winter. Okay. So basically, what's the next experiment? So let's see what the experiment says. Place a straw on the table on a bottle. Take another straw near it. Observe what happens. Basically, nothing will happen because these two straws are electrically neutral. Leave the straw on the bottle as it is. Rub the another straw against a woolen cloth. Now, as you rub it, it generates some static charges. Now, take the two straws and rub them against the woolen cloth at the same time. Now, if both straws are rubbed, both have same electric charge. If only one was rubbed, they would still attract. But since both are rubbed, both are made of same material, both will have same time of charge. We don't know it's positive or negative, but what we know is the charges are same. So what will happen? They will repel each other. Okay. Basically, this experiment that the conclusion is electrically charged particles attract uncharged particles, right? Because as I essentially explained, for example, it's a plus charge and there is a particle which has both plus minus charge. So after the exposure, the negative charge comes closer and the positive charge goes away. Effectively, that's still an attraction. Okay. So electrically charged atoms attract uncharged objects. There is repulsion between like electric charges. So how you know that an object is electrically charged or not? By repulsion is used as a test for identifying an electrically charged object. But remember, the both materials should be same. You will not be sure if they are attracting that. Okay, maybe. But yeah, repulsion means electric charge is present and they both have same electric charge. The next thing is that was observe and discuss. I'm discussing this. Take thermocol ball or mustard seed in a bottle and shake the bottle vigorously. The seeds try to move away from each other but stick to the bottle. Why? One of the possible reasons is that the static charges generate charge. Basically, mustard seed are made of same material, so they have similar charges. We know that. So they will repel each other. But it's a possibility that the plastic bottle will have different charges, and so they attract each other. Now, what we do is to charge an object by contact. Okay, rub a plastic comb against paper. Touch this comb with another uncharged comb. Okay, take the another comb near some pieces of paper. Okay, what happens? Ideally, the paper should attract. The second experiment is run a comb or balloon on your hair. Remember, the hair should be dry and not oily. As shown in the picture, take the comb near a thin trickle of water from a tap. See what happens. Now draw the comb away from the trickle and observe what happens. Now I'll not manipulate the observations. Okay, so I straight away come to the result. At first, the flow of water is not charged. Basically, what happens is paper and comb both are essentially neutral, so it's not charged. So, what happens is when a negatively charged comb comes near the flowing water, the negatively charged particles in the comb are pushed away. Okay, that part becomes positively charged due to deficiency of negative charges. The comb has negative and the water has positive. Okay, basically what happens is there is water flowing, there is a comb. Okay, so what it says is the negative particles near, it should be negative, the negative particles near are pushed away. Okay, this part becomes positively charged because the negative parts have been pushed away. The comb has negative, it's the other way around. The comb has positive charge, the water has both positive and negative charge. Just a minute, I'm so sorry for that. Now forget everything what I said. The comb has negative charge and water has both positive and negative charge. So what happens is this negative charges repel each other. So negative charges go backward while positive charges come forward. That is why the stream of water flows nearer to the comb. Okay, I'm so sorry for the confusion that might have taken place. Due to attraction between the opposite charges, the flowing water is attracted towards the comb. When the comb is taken away, naturally, when the comb is taken away, both positive and negative particles come back to the original position and the water becomes uncharged and stops getting attracted. Okay. Remember this, the second point, the electric charges generated by induction stays as long as a charged object is near to it. So remember, when you expose it to air, the induction charges go away. Okay. 1. Keep a spent tube light in a dark place. Rub it vigorously with a thin polythene bag. What happened? Why? Basically, this happens in old tube lights. The new LED ones, they don't have that phenomenon. You will learn about the phenomenon, what happens in your high classes. Okay, so when you rub it vigorously and you see, so a slight charges are induced in the polythene bag. Now the second thing is, take an uncharged aluminium ball near a negatively charged balloon. Okay, so basically the aluminium ball is uncharged. So what happens is, now the good thing is the figures are already there. The opposite charge is generated in the other object by induction. Okay, so it's negative, so it induces sort of positive charges for the time being. And both the objects are attracted to each other. As shown in figure B, on touching, both objects becomes similarly charged. When you touch, the object's charges flow from there to there. And when the charges are equal, they start to repel. Okay. So remember that if you want to have opposite charges, the two must not touch each other. The moment you touch, it's a similar same thing, the charges get passed on. Similar charges, mind it. Okay. So now this is a gold leaf microscope. So basically, it's a simple device to detect electric charges. What happens is, there is a copper rod on top. Copper is a really good conductor of electricity. Okay, so whatever charges are, they stick straight and go downwards, which has a metal disc at the upper end, metal disc, and two golden leaves on the other. The rod is placed in a bottle so that the disc is above the bottle. Now, when uncharged object, there is no charge there, so no charge induced there. The gold plates, they too stick. No issue, the object is uncharged. But when you place a charged object, as shown there, both the leaves are charged by same. This is induced electricity charge. The leaves which are traditionally like this, maybe not like this, matlab, it's a 3D structure. So they both have same charges. They repel each other. And you know that the object is charged. When we touch the disc with our hand, the leaves collapse. Because why? The charge in the leaves goes to the earth via our body and leaves get discharged. Good enough. So, great scientist, you can read it yourself. The one thing that really fascinates me about Benjamin Franklin, though, that he was flying a kite through the metal wire. Remember, when you are flying kite, do not use metal wire. Any sort of lightning will pass straight through you. Okay? That basically what good thing he did was that he proved lightning is a form of electric charge. Before that, it was thought of wrath of the gods as a supernatural phenomenon. But he proved that it's nothing like that. Okay? Now, we come to atmospheric electric charges. Now, the charges are induced in the atmosphere as well. Charges are present, as I say, charges are present everywhere, and air is no exception to this rule. Now, we have experienced clouds, thunder, and lightning. For the people near Mumbai, more so. Sometimes you hear that or read a lightning struck a tree or building, and some people or animal were killed. Okay, how did this happen? How can we prevent such death or injury? Okay, so what's lightning? When air and cloud rub against each other in the sky, the upper part of some clouds on the upper side becomes positively charged and the lower sides become negatively charged. The figure shows that upper part become positively charged and lower part become negatively charged. Okay, so why does this happen? It's a separate theory in itself. Okay, so consider that there is negative charges up there. Now the potential is building up, building up, building up, building up. The cloud cannot hold it. So what happens is it releases it to the ground. Like when, for example, if I have to give an example, consider a person who keeps getting angry, unless he releases his anger to the unfortunate person right besides him. So that is a case of the lightning. Okay, as it's mentioned, when this negative charge, the bottom of a cloud becomes much larger than the charge on the ground, it starts flowing through the ground in stages. This happens very fast, in less than a second, and heat heat, light and sound energy are produced. Okay. So now a lightning strike. What happens is that in not for low level areas, especially for people like hills, a strike is an issue. You have a cloud there and the strike comes like this. Okay, not maybe like this, it's a cartoonish character, but yeah, a strong light strikes. Okay, there are electrically charged, uh, you probably know that when there are electrically charged cloud occurs in the sky, electricity is attracted towards a tall building or tree, traditionally because they are neutral, and most of the charges they tend to go to either the opposite charge or they tend to go to ground. When lightning strikes, an opposite charge is generated on the roof of a building or on top of tree by induction. Now this is the case. Here you have negative charges and here on building you have positive charges. What will happen? The charges flow. Remember, these positive charges are induced by induction, and since these negative charges are there for quite some time, they are not removed easily. Okay. I am reading here. Due to the attraction between opposite charges on the cloud and the building, the charge on the cloud flows towards the building. This is called lightning strike. Okay. So we have learned that due to lightning, explained that in the nutrition chapter, that the nitrates are formed. Okay. The second good thing is that when lightning comes, basically the oxygen in the air, I'll try to explain it in as less complicated way as possible. The oxygen is split into two oxygen atoms. Sorry, that should be O negative and another O negative. Basically, it's a covalent bond. So, to be honest, there won't be a particular charge. So, O and O. This reacts with O2 to produce ozone gas, O3. And O3 is also unstable, so it may return to give O2. That's a possible science in itself. The nature has mastered it, how to maintain O3 levels. Now, due to the energy of the lightning, the oxygen in the air is converted to ozone. This ozone gas protects us from the harmful ultraviolet rays coming from the sun. Okay, ozone is really important, and as the ozone layer declines, the sunlight, the UV rays, which are the harmful components, will reach us and it may burn our skin. Okay, so a lightning conductor. Now, it's possible that if what is lightning conductor? For example, consider that if there is no lightning conductor, then the whole building is charged. So that whole outside building, if it's made of metal, though no buildings are made of metal per se, the whole building has a positive charge, and the electrical appliances going down there, they will have an issue. So what you do is you place a lightning conductor. So what is it? The lightning conductor is a device used for protection from a lightning strike. What is it? It consists of a long copper strip with one end forked. Basically, you can see it here. Forked end, this end, which attracts the light towards it. Oh no, it's not harmful, it's very useful property. This end is at the highest part of the building. Okay. The other end of the strip is to the ground. It's there at the ground and it's connected by the plate of cast iron. So a pit is dug in the ground, and to ensure better conduction, coal and salts are dug in. Okay, so basically remember that earth is like an infinite ground for charge. We assume any number of charges can go out to earth, or earth can supply any amount of charges. Okay, so basically there is also provision of pouring water. What the good thing is, this helps to spread the electric charge quickly in the ground and prevent damage. Now what happens is, as the cloud strikes this end, because of its pointy end, it generates more charges than the area surrounding it. So what happens is the lightning is attracted to this, and due to this much of the lightning passes through that. Basically the building is bypassed and the electrical equipments are easily protected. Okay, so it is written in the theory, when an electrically charged cloud passes over the building, the electric charges flowing towards the ground and the building are conducted into the ground through the copper strip, and damage to the building is prevented. When such a lightning conductor earthing is fixed on a tall building, the surrounding area is also protected. This you will learn in much details in disaster management. Okay, thank you.